Hello everyone, my name is Rafael. I am an electrical engineer, and in this video I would like to draw your attention to an exercise concerning ideal amplifiers. I am going to read the exercise and show you the solution. Let me do this. Ideal amplifiers. Consider an amplifier operating from plus minus 10 volts. Power supplies. It is fed with a sinusoidal voltage having 1 peak, 1 volts peak, and delivers a sinusoidal voltage output of 9 volts to a 1 kilo ohms load. The amplifier draws a current of 9.5 milliamperes from each of its 2 power supplies. These currents here. The input current of the amplifier is found to be sinusoidal with 0.1 milliamperes peak. Find the voltage gain, the current gain, the power gain, the power drawn from the DC power supplies, the power dissipated in the amplifier, and the amplifier efficiency. Okay, my friends, this is the exercise. Let's solve it. First of all, the voltage gain, AV, is defined to be the division between the output voltage and the input voltage. We are going to use here peak values. The peak value of the output voltage is 9 volts. And the peak value of the input voltage is 1 volt. Then we find that the voltage gain is 9 volts per volt. Okay? Did you guys understand? And now, using the logarithm, we can express the voltage gain as follows. The voltage gain in decibels is going to be equal to 20 times the logarithm of the voltage gain that we just calculated. It is then going to be 20 times the logarithm of 9, which is approximately equal to 19.1 decibels. 19.1 decibels. This is the voltage gain expressed in volts per volt, and this is the voltage gain expressed in decibels. Now let's calculate the current gain. To calculate the current gain, first of all, we need to calculate the output current. We are going to use these values here the problem gave us to calculate the output current. The output current is going to then be equal to the value of the output voltage divided by the value of the load resistance, which is 1 kilo ohms. And then we find 9 milliamperes. We are going to use this value to calculate the current gain. The current gain, by definition, is the division between the output current and the input current. Okay? We are going to use peak values here. 9 milliamperes divided by 0.1 milliamperes. And then we find 90 amperes per amperes. Are you guys understanding everything? Okay? As we did before, we are going to express the current gain in decibels. The current gain in decibels is going to be equal to 20 times the logarithm of the magnitude of the current gain. We found the current gain to be 90 amperes per ampere. We just substitute and then we find that the current gain expressed in decibels to be 39.1 decibels. These are alternatives. You can express the current gain as amperes per ampere or in decibels. Now let's find the power gain. The power gain, by definition, the power gain is the division between the power delivered to the load and the input power. First of all, let's calculate the power delivered to the load. The power delivered to the load is going to be the multiplication between the RMS values of the output voltage and the output current. remember that to find the RMS value, we have to divide the peak value by the square root of 2. And then we find the value of 40.5 milliwatts. Now, let's calculate the input power. The input power is going to be the multiplication between the RMS values of the input current and the input voltage. Remember, again, to find the RMS value, we have to divide the peak value by the square root of 2. And then we find 0.05 milliwatts. We can simply put these values here and here in this expression here. And we are going to find 810 watts per watt. Now, subsequently, if we want to calculate the power gain in decibels, we are going to use the logarithm. The power gain in decibels is equal to 10 times the logarithm of the, now here we don't need the absolute value, okay, of this value here, AP, we just calculated it, and then it is 10 times the logarithm of 810, which is approximately equal to 29.1 decibels. This is the power gain in watts per watt, and this is the power gain in decibels. Next, we are going to calculate the power drawn from the DC power supplies. This and this. PDC will be equal to V1 times I1 plus V2 times I2. The power drawn from the DC power supplies is going to be equal to V1 times I1 plus V2 times I2. Which is equal to 10 volts times 9.5 milliamperes. As they are equal, we must only multiply by 2. Okay? Very good. And now we find 190 milliwatts. So this is the power that the DC supplies give to the circuit. Next, we are going to calculate the dissipated power To calculate the dissipated power, we are going to use the equation PDC plus PI equal to PL plus P dissipated. The DC power plus the input power is equal to the power delivered to the load plus the dissipated power. Therefore, the dissipated power is going to be 190 milliwatts plus 0.05 milliwatts minus 0.05, and then we find the dissipated power to be equal to the dissipated power is 149.6 milliwatts. This power is dissipated in the component. And lastly, let's calculate the efficiency of the amplifier. The efficiency, by definition, is the power delivered to the load divided by the DC power times 100%. And we find this, if we use the values that we just calculated, we find it to be 21.3%. Okay, my friends, this was the video that I wanted to make. I hope you guys learned from it and enjoyed the video. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye.